Hello everyone, my name is Kumar Ankul and I am a third year undergrad of IIT Bhubaneswar. So in last video I explained the working of moving average filter, taking the example of pulse data collected from the pulse sensor. So in last video we calculated the pulse sensor of a human beings from the data collected from the pulse sensor. In this video we will take the real data in real time using the pulse sensor. So I have connected the pulse sensor with the Arduino board. So I will be collecting the data from that pulse sensor in the real time. So I'll be explaining line by line of my code. So firstly I have taken the sample size n equals to 150 and I have declared an array of float data type to store the sample taken by the pulse sensor. So this is the order of differentiation filter, L1 equal to 5 and L2 equal to 15. So this float dn is the array after passing through the differentiator filter. So this is my setup function. So this is delay function which will give 3-second delay just to calibrate the initial delay, and this is pin mode A0 that will be set in input mode. So that will be used to take data from the pulse sensor, and this is the maximum value and minimum value declaration. So I have declared a maximum value and a minimum value so that I can find simultaneously the maximum value of the data collected from the pulse and minimum value from the data collected from the pulse. So I will be explaining the reason behind this maximum and minimum value calculation later part of the video. So this is my loop for collecting the data from the pulse sensor. So this will be going from I equal to 0 to I equal to 149 till the size of the sample. So here it's simply taking data from A0 pin of the Arduino, and in A0 pin pulse sensor is attached. So now this is the serial begin, the baud rate of the Arduino. So this is 9600 you need to set. So this is my normalization function. So in this function I have taken the data collected from pulse to the mean 0 and I have divided with maximum value to get data from -1 to 1, so that I can get all the samples size from -1 to 1. So this will be easy to find and process the data further. So this is for loop which to plot those normalized waveforms. So followed by this line. This is all which I have explained in my last video. So this is all in last video I have done. So now I will print the code. So you can see the output. So I have put my finger on the pulse sensor. So I will upload this code. Once it uploads we can get the data. So we can see that original data, then the smoothened data, and then the differentiated output data, and then we can see the output as this serial monitor. You can see data coming from the pulse sensor. So it will calculate the, so it's calculating pulse rate as 96.77. so there may be some ambiguity or noise, so it can be accepted. So thank you for watching the video.